Okay, now we're going to look at geometric sequence using logarithms. Now, with geometric sequence especially, you must remember your logarithm rules very, very well because a lot of questions require using logarithms. Okay, so remember the basic one where a to the power of x, okay, if x is on the power, equals to some number b, then we can find x using our log rules. X is basically, so make x a subject, equals to log a b. Okay, that's the rule. Hope you remember something like this, guys, or at least it's familiar for you. Okay, this is a basic log rule. Okay, so when you're doing a question regarding geometric sequences, you may get to a point where it's in the form of a to the power of n minus 1 equals to p, where n is on the power. Okay, so to solve for that n, we need to use logarithm. So the power n minus 1, or the power here is going to be x, becomes a subject. So n minus 1 becomes a subject, and that equals to log a, so that a goes down. See how here that a goes down as well? So that a goes down, so it becomes a little a here, and then the p goes after the log. See how here b goes after the log? So therefore n minus 1, the power, equals to log a p. Okay? And therefore to solve n, simply move -1 over and make it log a p plus 1. And that's the value of n. Okay? So even if you have a power on the as the n, so if you have the pronumeral on the power, you can simply use some log rules to find that power, okay? So that's why you're going to be really familiar with your log rules, just like this one here. Alright, so let's try apply that onto our questions. I'll show you when we use logs during our geometric sequence questions, okay? So starting with question 10, it says consider the sequence 7, 14, 28, etc. Okay, so this is a sequence. It will probably go on and on and on. Now, part A says find the largest 6-digit term. Okay, what does that mean? Largest 6-digit term. Okay, the largest 6-digit term as an integer is probably 999999. Okay, that's the largest 6-digit term as an integer, isn't it? Right? That is just below 1 million, isn't it? 1 million is the smallest 7-digit number, isn't it? So the largest 6-digit term would actually be this one, but we want to find the largest 6-digit term in this sequence. Okay, that's basically what they're asking us to find. Now before we do anything, I'm going to find what my A is and what my common ratio R is. Okay, hope you can see that A is definitely going to be 7, which is the first one on the list. So A is 7, so that's pretty easy to find. Now R is going to be 2, since 7 times 2 is 14, 14 times 2 is 28. So we found R straight away as well. Okay, so I've got A, we've got R. All we need to do now is put it into our formula, A times R to the power of n minus 1, like this. So 7 times 2 to the power of n minus 1 is less than 1 million. And the reason why I put less than 1 million, the reason why I put an inequality sign is because of the thing that I just told you previously, that this is the largest 6-digit term as an integer, okay? And that is just less than 1 million, since 1 million is the smallest 7-digit number. See how this is 1, 2, 3, 4, 5, 6, 7 digits? Okay, but this is probably not the answer for this one, because we want to find the largest 6-digit term in this sequence. Okay, so how we do that is by finding the value of n, okay, for when the whole term is less than 1 million. Okay, just less than 1 million. That's why I made it an inequality sign like that. Okay, so I hope that makes sense, guys. This is something you must understand, okay? This is a very common occurring question. Okay, so have a look at that. That's basically why I put this kind of sign. Okay, and this is the reason why I chose 1 million as my number. That's the smallest 7-digit number. Okay, so we must find a number just before that. Okay, let's solve it, guys. Okay, let's solve the inequality. I'm going to just divide by 7 first of all to get rid of that 7. So I have here 2 to the power of n minus 1 left, and over here we have 1 million divided by 7. Okay? Now that we've got that, I'm going to find my n by making that, I'm going to use my log rule now. Make n minus 1 the subject, or it's not equal to because it's less than, so use your inequality sign. Keep your sign following. Log, that 2 goes down, and this number goes after the log. So 1 million over 7 is over here. Okay? So basically, guys, all I used was ax equals to b, x equals to log a b form, b rule, this rule. That's all I applied here. So the power becomes the subject, and we have log 2, and then that, like we have here. Power becomes the subject, log, a goes down, b goes after the log. That's all I used, guys. Okay, so please be familiar with this. So see how now n is no longer on the power. Guys, find 1, okay? Find n by simply moving 1 to the other side, just like this. N is going to be log 2, 1 million over 7, plus 1. And sorry, n is going to be less than because of that inequality sign. Now, n is simply less than 18.124. Now, for those who have forgotten how to get that number, now guys, in your calculator, there's no log 2 button. There's only log 10 button. You know the log button on your calculator? That button means log 10. Okay, that's a little button for log 10. Okay, and you also seen the ln button. This ln button is log e. So I'll just write over here. That's log. I hope you remember this stuff though. This shouldn't be anything new. Okay, so if you really don't understand, you must go back to your log section and remember that and revise that. Okay, this is ln. So ln is log base e. Okay, so to get to this number here, or to solve or simplify what that is, I'm probably going to go like this. Remember the rule, this part is going to be log 10, 1 million over 7 divided by log 10, 2. I'm going to rub this off now, guys, so please understand that. Plus 1. Okay, so this part, how did I get this? Guys, remember the rule? Log AB, this can be changed to log CB over log CA. You can make it into a fraction like this and separate your B and A as long as you make the base C the same on top and bottom. Okay, so, and I hope you remember this as well. If you really think this is a totally new thing for you, you must go back to your logarithm section, okay? Okay, so now I'm going to apply this rule onto here. So see, I decided to make my C, and you can make your C whatever you want, right? So I made it 10, because there is a log 10 button on the calculator. So if I make that 10, and if I make that 10, I can just type it in the calculator, can't we? So this number goes on top, the base 2 goes on the denominator like that, and then we simply plus 1. And guys, all you need to do now is put it in your calculator. Okay, go log 10, 1 million over 7 over log 10, 2. Log 10 button is basically just the log button on your calculator. Okay, so just type it in, and you should get 18.124, etc. I just rounded it off. Well, not rounded off, I just use dot dot dots. Okay, so something roughly that kind of number. So what's n going to be? Which term is going to indicate the largest 6-digit number? The number, the n, must be less than 18.124, but we can't have term 18.124. That does not make sense. It's like having 18.124 people. That does not make sense, right? So therefore we must find the closest integer, okay, that's less than this number, so n is going to be 18. We can't have 19 because 19 is greater than 18.124. So the number that's smaller than 18.124, that's an integer, is going to be 18. Alright, so n is 18, but it's asking us to find the largest 6-digit term, which means we want to find the 18th term. Okay, n equals to 18 means term 18 has the largest 6-digit term. So, what is term 18? Term 18, we simply sub it into our a times r to the power of n minus 1 formula. A is 7, r is 2, n is 18. So sub in 18 here. So it's going to be 18 minus 1. Put that in your calculator. You should get this number here, okay? 917,504. All right, 91,000. How do I read this? 917,504. It's a big number, isn't it? So this is the largest 6-digit term, okay? And see how it's 6 digits, and it's 917,000 something. So I'm assuming this will be the largest 6-digit term that's in the sequence. Okay, so that's the answer for question 10a. Alright, so with this one you must find what n is first, and then you must also put it back into your formula, and then find out what that term is. Okay, so I hope you understand this inequality concept, why I used less than sign. Okay, and I hope you can decide if it's going to be 18, is it going to be 19 here. Okay, I found that it's 18, and make sure it's an integer. It can't be some decimal number like that. Okay, and then you sub it in, you get something like this. That's the answer for question 10a. Alright, and guys, as I keep repeating, you must know your log rules very well. Okay, if you don't already know, you must go back to your log section, because that's very important knowledge in this section. Alright, that's A. Let's move on to B. Find the smallest 4-digit term. Okay, this time they want us to find the smallest 4-digit term. Okay, so what I'm going to do is say, you still use our same formula, 7 times 2 to the power of n minus 1. It must be greater or equal to 1,000. Okay, this term must be greater than 1,000, or it could be equal to, because 1,000 is also a 4-digit number. Now it must be the smallest 4-digit term, so because 1,000 is the smallest 4-digit term, right? Yeah? Can you see that 1,000, there's 4 digits in that number, that's the smallest 4-digit number, isn't it? So it can be equal to that, since that's also a 4-digit number, and it can be slightly greater than that as well, because that's what will also indicate a small 4-digit term. Okay, but we need to find that term which is in the sequence. That's why I put this expression, okay, greater or equal to 1,000. Okay, so we've got to find the value of n in this case. Let's do it. First by dividing both sides by 7. So it's going to be 1,000 divided by 7 over here, and here we have 2 to the power of n minus 1 left. Now we must use our log rule again. So the power becomes a subject, so n minus 1 is our subject. Keep your sign following as it is, and then it's going to be log, 2 goes as a base, and then 1,000 over 7 just goes after the log. Okay, and then to find n, you simply move 1 over and make it plus 1. Alright, and again guys, use your same kind of thing here to find what this value is. If you want to put that in your calculator, again do something like, I'll try to do log e this time. Log e, you can put anything you like as the base, as long as the base on the top and bottom are the same. So log e, 1,000 over 7 over log e 2, because the base is 2. Okay, and then of course plus 1. Put this in your calculator and then you can solve it. Okay, log e, guys, remember that is the ln button on your calculator. So log e, just press your ln button and then go ln 1,000 over 7, ln 2 plus 1, and then you should get the answer for n. Okay, so I'm going to rub this off now because I want to show you the answer. So think about it, guys. Put it in your calculator and you should get something like this. N is greater or equal to this value here that you put in your calculator should be 8.1584, etc., etc. Okay, dot, dot, dot. Now, think about it, guys. Again, n must be an integer. It can't be some decimal number like that, because it cannot be the nth term, okay? It cannot be 8.1584th term, okay? That does not make sense, so we've got to find the closest integer that makes n greater than this number, okay? N has got to be 9, okay? Because if n is 8, it's not greater than this, but 9 is greater, isn't it? So n is 9. So the ninth number is the smallest term. It's the smallest 4-digit term basically. Okay, so we've got to find what that ninth term is by substituting this back into our formula, 7 times 2 to the power of 9 minus 1. And that should be simplified to 1,792. Okay? So the smallest 4-digit term in this sequence will be 1,792. So basically this means that this is the first number after 1,000. Okay? So the term before this would probably be less than 1,000 since this is the smallest 4-digit term. Okay, so I hope you're understanding what I'm saying. Okay, so question 10C is asking us to find the number of terms in the sequence between 1,000 and 1 million. Okay, so how many terms are in between that? That's within this sequence. Okay, so basically guys, this is part C. I want to try to utilize what I have in part A and B. Okay, remember in part A we found the largest 6-digit term. Okay, remember that was term 18, wasn't it? Term 18, okay, was the largest, had the largest 6-digit term, wasn't it? It was $900 and something thousand dollars. So question 10C is asking us to find the number of terms in the sequence between 1,000 and 1 million. Okay, so it's asking us how many terms in between these two numbers within the sequence. Now guys, this is part C. I want to try to utilize what I had in part A and B. Now remember in part A we found the largest 6-digit number that was in the sequence, wasn't it? And we found that it was I think it was the 18th. The 18th term was the largest 6-digit number, yeah? And in part B we found the smallest 4-digit number, which was, I think it was the 9th number. The 9th number was the smallest 4-digit number, yeah? So, therefore, so the 9th number was 1,000 something. That was the first number after 1,000. Okay, so the first number after 1,000 is the 9th number. And remember how the smallest number, or actually the largest number that had 6 digits was the 18th number, and that number was just before 1 million. So the last number just before 1 million would be the 18th term, isn't it? So therefore, between 1,000 and 1 million, these are the terms. It starts from term 9 up to term 18 basically. Okay? Hope that makes sense. So the first number after 1,000 is term 9. The first number that's just before 1 million is term 18, as we found in part A and B. Okay? So, how many terms between term 9 and 18? Guys, some people say there's 9 terms because they do 18 minus 9. But think about it, guys. There's 9. From 9, there's 9 to 18. There's actually 10 terms because if you count it up, including 9 and including 18, there should be 10 terms, not 9. Okay, don't just subtract 9 from 18, okay? So therefore, there are 10 terms between 1,000 and 1 million. Okay, so if it's 9 and 18 inclusive, it should be 10 terms, one more than the difference. Okay, so 9 plus 1, which is 10. So there's 10 terms, including term 9 and term 18. Okay, so basically here, I'm adding up how many terms there are in between those two. Term 9, term 10, term 11, term 12, up to term 18. There are 10 terms. Okay, that's the answer to question C. That was pretty simple, wasn't it? Okay, so but this one you really need to think about it, and you really need to think about what you had in part A and B, okay, in order to do this question. If you understand it, then it's actually really, really quick and simple. Okay, so that's question 10, guys. That was basically how we used logarithms in our geometric sequence. So as I keep repeating, guys, you really need to know your log rules for this one, okay? Because it's used, these questions, they involve a lot of logarithms, especially in your exam questions. I'm pretty sure they will have logs in your questions, okay, while you're solving. Okay, so please familiarize yourself with them. That was question 10.